All right, part of working with radicals, you're going to end up with problems where the radical is actually in the denominator. And we don't want the radical in the denominator. So what we do is we do something called rationalizing the denominator. We do not leave radicals in the denominator or square roots in the denominator or cube roots or anything in the denominator. So what we have to do is, for instance, let's say I have the square root of 2 times the square root of 3. Okay, my denominator, I have square root of 3 down here. I don't want that down there. I want the square root to go away. So what I'm going to have to do is I multiply by this other fraction. I multiply by the square root of 3 over the square root of 3. So I'm multiplying, essentially, I'm multiplying this purple fraction by 1, because anything divided by itself, square root of 3 over square root of 3 is 1. 2 over 2 is 1. 4 divided by 4 is 1. Anything over itself is 1. Divides out. So I'm just multiplying this by 1. And I do that in order to get this square root to go away. So let's look at how that happens. So in the top, I'm going to have square root of 2 times the square root of 3. Now remember, we've got that rule, and I'll put it in letters. Say we had square root of a times the square root of b. And that is the same thing as square root of a times b. As long as these are the same root, meaning we're taking it both to the cube root, both squared root, both fourth root, whatever, I can multiply what's underneath. So I have square root of a times square root of b equals the square root of a times b. So up here, square root of 2 times the square root of 3, I'm going to have the square root of 2 times 3, which is 6, over the square root. Now I'm going to have 3 times 3, so I'm going to say 3 squared. Now what have we said repeatedly? A square root and a square do what? They cancel. Square root and a square cancel each other. So I'm left with the square root of 6 over 3. Now I always have to ask myself, can I simplify the square root up in the top? Can I simplify that any further? Square root of 6. And I'm going to think about it, and no. There's no perfect square that goes into 6. So square root of 6 is completely simplified. So you have square root of 6 over 3. All right, let's work a different example. Let's work, say we had 4 square root 2 over the square root of 12. Okay, again, we don't want that square root down in the bottom, so we're going to multiply by the square root of 12 over the square root of 12. That way we get 12 squared in the bottom, and we can cancel out our square root. So I'm going to have 4. Now I multiply what's underneath the radicals. 2 times 12 is 24. So 4 square root 24 over the square root of 12 squared. So I have 4 square root 24 over 12. All right. Now this is not completely simplified because first of all, 4 and 12, those can simplify. All right, so 4 divided by 12 or 4 over 12, if I was going to simplify that, that's just a fraction, right, is 1 over 3. So I end up with the square root of 24 over 3. All right, now the square root of 24, there is a perfect square that goes into it. 4 is a perfect square, it goes into it. So I have the square root of 4 times the square root of 6 over 3. Square root of 4 is 2, so I end up with 2 square root 6 in the top, all over 3. And that is my completely simplified answer. 2 times the square root of 6 over 3. I can't simplify 2 over 3. That's a completely simplified fraction. And square root of 6, I can't simplify either. That is a completely simplified square root. All right, stay tuned for the next video because we're going to work through lots more examples on these.